Alright, now we have topic 2.2, which is titled More Points, Lines, and Planes. In topic 2.1, our previous topic, we learned definitions of a point, lines, the different types of lines. We discussed rays, opposite rays, and we learned what a plane was. What we will go over on this lesson, we're going to talk about a couple of postulates, which are statements that are assumed to be true, and we're also going to look at theorems, which are important statements that must be proven. Now, whenever we're going through this, the first of this lesson, we're going to talk about some statements that will be the postulates that are using or involving points, lines, and planes, a couple of theorems, and then we will get to a couple of examples which will actually show you some of these postulates and theorems. Alright, so let's look at the first part of our notes. And the first part involves postulates. We're going to talk about some of the postulates that we have. And postulates, as you can see on the top of your notes, they are statements that are assumed to be true. So the first one, it says, through any 2 points, there is blank line. Through any 2 points, there is exactly 1 line. Exactly 1 line. Alright. Let's move to our second one. A line contains at least 2 points. So a line, just like whenever we label it, A, B, with a line over the top of it, it has to contain at least 2 points. Alright, a plane contains at least 3 non-collinear points. Alright, a plane contains at least 3 non-collinear points. There's 3 points inside a plane, and they are not all on the same line. Alright, through any 3 points, there is at least 1 plane. At least 1, doesn't have an E on it, 1 plane. So through any 3 points that you have, there's at least 1 plane. So if you have 3 points, they don't have to be, they're not going to be in a line, but any 3 points you have, there will be at least 1 plane on those 3 points. Alright? Through any 3 non-collinear points, there is, if you have 3 of them and they're not in a line, there is only 1. So there's exactly, let's put it that way, there's exactly 1 plane. There's 1 plane through any non-collinear points. Alright, space contains at least 4 non-coplanar points. And we have here, if 2 points are on a plane, then the line that contains the points is also in the plane. So if 2 points are on a plane, then the line that contains the points are also in the plane. Let me draw that real quickly. We have a line. Put my 2 ends on it here. Put 2 points, A and B. Point A, point B. Now here we have 2 points. And let's draw. I'm going to draw a plane out here. Here's my plane. We'll have to imagine we'll have the arrows going infinitely in all directions. But if there are 2 points in a plane, here's our 2 points. Then the line that contains the points, this line right here that is containing these 2 points, is also within this plane. This plane will continue in all directions. So will this line. They will draw these little lines down here. Continue indefinitely in all directions. Alright, be sure I would draw that out to the side if you need to. Alright, let's look at our last postulate here. It says if 2 planes intersect, then their line, if 2 planes intersect, their intersection is a line. Get my right color here. Didn't quite grab it. Their intersection is a line. Alright, and I have an image that I took to demonstrate such. Drag it over here into the screen. I took 2 index cards. I cut them and put them together. This would represent one plane. This would represent another plane. Right here where they intersect, there's a line. These planes continue in all directions. This portion right here is the line where they intersect. It will continue indefinitely. At the bottom of our notes, we have our theorems, which are important statements that must be proven. We must prove these. If 2 lines intersect, then they intersect at a point. They intersect at a point. And then our last one, if 2 lines intersect, then exactly one plane contains these lines. Then exactly one plane contains these lines. So I'm going to draw 2 lines here and they're going to intersect. I can draw points. Point B, C, and we'll call this one point A. Now, if 2 lines are intersecting, this is where they're intersecting at. Exactly one plane will contain these lines. So there will be a plane. And a plane. Granted, that's not drawn very well, but this plane will contain both of these 2 lines. You have to see this in a 3-dimensional. You have to view it in your head as 3-dimensional. If I took this portion and lifted it up, it would be like a sheet of paper. It would lift all the way up. The arrows, the lines would then, they're not continuing here. They look like they're going to continue downward. They would shift. And then they would continue more of an upward if you lifted this corner up right here. If you took this corner and lifted it upwards. Imagine lines on a piece of paper. You can take a piece of paper and you can draw these 2 lines. Hold it down where you're looking at it and slowly rotate it upwards. And you will see that that is a plane. And it's very important that you get that concept, that you grasp that. And that these 2 lines, they're following on that plane. These lines, they don't continue down through the plane. They're on that plane. And that'll be very, very critical that you understand that when you look at this stuff, it's out in 3D space. It's not 2-dimensional, which is what we see here, unfortunately. It's very difficult to see things in 3D. A lot of people, they want to look at lines. They want to look at planes as a 2-dimensional figure, but this is 3-dimensional. You can get below this plane. You can be above this plane. It's very important that moving forward you learn to look at these in that manner. Alright, so now let's move to our examples. And I have here example 1. I have an attempted drawing at what you'll see with example 1. And let's look, it tells us, or it asks us, it says things that we know from the picture. It wants to know what we know from this picture. We can look, and we have here a plane R, and we have a line that is a line AC, and it intersects, shown by this dotted line. It's going to intersect. It's going to go through it. Imagine you have a pencil sticking through an index card, and the pencil comes all the way through, goes out the bottom, and then you can continue to see it through the bottom. Right here, you won't actually see it. This is only shown here to prove to us that this is a line that continues through it. So let's look at things that we know from that. It's asking us for five things that we know. Grab a color here. Is there points that are coplanar? I see we've got points that are coplanar, which is 3 points that lie on a plane. So we can say that X, B, and Y, but and Y are coplanar. And the same with that is we have 3 points that are on the same line. So we can find those points. What points are all on the same line? We have this line right here, A, B, and C. A, B, and C are collinear. Alright, something else that we can figure out. We have a line here, and we have a plane, and they will intersect. The question is, where do they intersect? Well, they intersect here at point B. So we can say that plane R, which I'm going to use the scripted letter here, the uppercase script of an R, and now we're looking at a line, which I'm going to label our line AC, AC, and it's very important, and since it is important, I'll put a different color. And when we label this, we use our proper way of naming the line. So plane R and line AC, they intersect at B. That's something that we know from this. At B, just a capital letter for point B. Let's see what else. We've got a couple of rays in this. Where are the rays? You have BC, that is a ray, and you have BA, those are also rays, but what are special about those rays? One's going in one direction, one's going the opposite direction, so that makes them opposite rays. Are opposite rays. And something else, let's say there's a line that goes through BY. Something that we just talked about. We've got a line. I draw this line right here. There's a line that goes through BY. Well, that's contained in our plane R. So we can say that BY is a line is contained in plane R. Now, there's a lot more things that you can find about this. You can say BX is contained in plane R. You can say you have a ray in BY that is contained in R. You can have line XY. You can create rays out of XY, XB. You can create a ray. You can create all of these using any of these points. Now, example 2 I'm going to leave for you, and let's continue on to example 3. Now, let me remove example 1 and pull up example 3. I know this figure is not exactly what you might see there. It's as close as I could get drawing it. I tried to draw it to where both planes stuck out, and they were differentiated by colors here. So let's use this figure to answer the questions in example 3. A asks us to name 3 points that determine plane J. So we have this plane right here, and we're going to determine using 3 points. This is the intersection, and these 2 points are on the intersection. Therefore, we can use those, and we're going to say that they are on plane J. So our 3 points that we can use a V, a W, and Z. Alright, name the intersection of planes J and K. We just talked about that. That would be this line. You can name this line using several different ways. You can name it, you can say, well, this is going to be line UW. You can say it is line VW. You can say it is line VU. There's several different ways that you can name this line. There's no scripted letter, lowercase script letter that you can use, but we can use the points, any 2 points on that line. C, name a set of collinear points and a set of non-collinear points. Well, let's look. I'm going to put collinear and non-collinear. Alright, collinear points are 3 points on the same line. Well, we just talked about our line. Here's our line. We've got 3 points on it. So you have U, V, and W. Those are collinear. Non-collinear, well, pretty easy. We can use V and W. We know they're on the same line, and let's pick one that's not on the same line. Let's use Z. That would be an easy example. We could also pick any 2 points that you pick. Say we pick V and Z. We can make a line through that. We can draw a line that comes through V and Z. Now we've got to pick one that is not in this line. Well, an easy one that we could also use would be X. Alright, and D, it says name a set of points other than those in example 1. When it says example 1, it's talking about part A up here. It says those in example 1 that are coplanar. We want 3 points that are coplanar. That's something different. It's got to be different than that, than our V, W, and Z. Well, we talked about this plane. We've named all the 3 points that are on plane J. Now let's look at plane K. Do we have 3 points that are on that we can use? I believe we do. We can use our V. We can use our W again. It's after 3 points, so we're going to use the other point, which will be point Y. And these are going to be any 3, just so that we remember, these are any 3, non-collinear points. We've talked about that. So, as a quick rundown, we did 3 points that determine plane J, being V, W, and Z. Name an intersection of J and K. We can use any any of those three in any order. You could also switch them around. You could have U, V, so on and so forth. We've got three non-collinear points, V, W, and Z, V, Z, X, and three collinear points, U, V, and W. And lastly, other than what we used in example 3, part A, what are three, or name points, a set of points that are coplanar? We've got to use three non-collinear points, V, W, and Y.